Hi guys, today let's look at the Lintcode problem number 116, jump game. Again, this is another dynamic programming. So let's look at the description. You're given an array of non-negative integers and you're initially positioned at the first index of the array. And each element in the array represents maximum jump length at that position. And you need to determine if you're able to reach to the last index. Let's take a look at this example. For example, you got an array of A and the numbers is here. And you need to determine that if you started with the first elements, which is 2, if you can jump to the last one, which is to 4. The first one definitely it works because you started with the first element, which is 2. So that means you can jump 1 step or you can jump 2 steps because based on the description, each element in the array represents your maximum jump. So you can just jump less equals to that length. So you can choose jump to 1 step or jump 2 steps. If you choose jump 1 steps and you reach to 3, and you can choose to jump maximum 3 steps. When you jump 3 steps, you're going to reach 4. If you choose to jump 2 steps at the very beginning, you reach 1. And you jump 1 step, you reach another one, and you jump 1 step, you reach to the end. So for the first example, it is working, always working. But for second example, let's say you started with 3, you have, you can jump 3 steps. For example, you just jump 3 steps, 1, 2, 3, and you reaches to 0. So that means you're trapped. You cannot go anywhere. Or you can choose to jump 2 steps, you reach 1, and jump 1 step, you reach 0, and you're trapped again. Again, you can choose to jump 1 step, you reach 2, and you can jump 1 step or 2 step, but no matter how you jump, you will be trapped. So the second test case will be false. So that's our problem. Again, we're gonna choose the dynamic programming. Why is that? Because we have some keywords in the problem. The keywords is that able. Are you able to do this or not? So you have to know that dynamic programming is good at answering questions like feasibility, if you can do this or not, if it is feasible or not. So pay attention to these keywords. So that's why we choose the DP for this solutions for this algorithm. All right, so if we want to use DP, we need to complete 4 questions. We need to answer 4 questions. Once we can answer all of them, then we can resolve this issue. The first is that we need to give a definition about DP. We have to use the DP array. It could be 1, 2, 3 dimensionals. So we need to choose the definition. And first way, we're going to just use 1 dimension because we're just dealing with 1 array. And second, we need to give a definition like DPI. What does it mean? For DP dynamic programming, we always just look for the definitions from our problem descriptions. Usually, our DP definition just quite close related to our answer, because our answer is like feasible or not. If you can reach to the last. So here is how we define the DPI. DPI means that if we can reach the index I. So that's DPI. All right, so by the definition 1, we need to answer the second question. What will be our answer? Our answer will be DP last index, because we want to know that if we can reach to the last index of this array. So that's going to be DP last index. No problems, right? No problems. Okay, that's great. So third, we need to figure out what is the state transfer equation. Today, the DP, the state transfer equation is going to be using the intermediate state. You probably just heard this a lot. You probably, have seen these techniques before. Today we'll be using this one, intermediate state. You got to memorize it. in your brain. It's just super important. DP use this kind of techniques quite often. Use the intermediate states. What does it mean? Our goal is to calculate all of the DP, and to calculate DPI, we cannot just define a adjacent states like DPI minus 1 or DPI plus 1. We cannot find a obvious relationships between I minus 1, I plus 1. So we can just change our mindset to look into another angle, which is that if we can just find an intermediate states like a DP, for example, DPJ. If we can find a DPJ, obviously DPJ is from 0 to I. If we can find a DPJ intermediate state, this we can reach to a J position. So that means DPJ equals to true. And also we can jump from J to I. So by the description, the condition should be AJ. AJ means how many steps we can jump, and J actually is our current position. So if how many steps we can jump plus our current position greater than I, that means we can jump from I to J. So question is that you find an intermediate state I, you can you found a intermediate state J, and you can reach to J, and you found a condition that J can reach I, so you can reach I, right? So that's the state transfer equation. If we can solve the intermediate one, and that is true, and we can also find a conditions relationship between the intermediate state and this state we want to calculate. Then if that happened, then we can calculate this guy. So this is the whole idea. Right, also third part is done. Let's say initialization. Because this is one-dimensional array, so it is usually always simple to initialize. We just initialize dp0 equals to true. What does it mean? dp0, that means if we can reach the first element in the array, definitely yes, because we started with the first element. So dp0 is 100% yes, it's true. All right, finally, we answered 4 questions, and it's time for us to jump into the code to implement it. And first, we need to initialize our DP array. Obviously, DP array is the same size our problem size, so we just use false multiplied by the length. Now we got a DP array, and we initialize them to false, and we initialize the first elements to true. That means we can reach to the first element in the array. And second, we're going to just try to use a for loop from 1 to all the way to the last. We need to calculate all the DPI, because once we calculate DPI, then we can just calculate our answer, which is return, right? But it's hard to directly calculate DPI, so we need to find an intermediate states. So that's why we have a second for loop. So in the second for loop, we actually is the intermediate state. So the intermediate state actually is from 0 to I, and not equal to I, right? So this is intermediate state. So we're gonna check if we can find this intermediate state. We can reach to that state. That state is true. We can reach to a position J. And position J, from position J, we can jump to position I. That means we can jump to position I. So that's what it is about. So if we found this satisfied, and we just mark this guy as true, then we'll just break, because we just want to calculate feasibility, and feasibility can be multiple different situations. So as long as we can find one, so we'll say DPI equals to true, and we just break. We just continue to next I. So once this is done, you just calculate all of the DPI. So answer will be so simple. We just return dp length a minus 1. Alright, so let's just calculate. Let's run this. Yeah, it looks like everything is fine. This is great. So 100% pass the test. So that's awesome. And also, I have some notes. The notes is Chinese. If you know Chinese, that would be awesome. So you can just say the notes. If you don't know, it's fine because I already covered in this tutorial. Alright, thanks. That's today's algorithm. And thank you. I see you in next tutorial. And by the way, if you like this video, you just click that subscribe. You will get my latest update. Alright, thanks. Have a good one. Bye bye.